I'm fairly fresh to this whole flat Earth, globe Earth debate.
Sextant could only work on a flat plane.
Hope it's not going over your head.
I mean, some of it I am struggling to understand, so it's possible I'm missing bits of it. That's absolutely possible.
Could be just fighting against a cognitive bias that you have.
I certainly think that's something that humans struggle with, myself included.
Indeed. I should have more empathy, but the arena has rubbed all that out of me.
Doesn't prove a sphere. The reason I brought it up is because I'm curious to know how it works on something flat.
Sextant could only work on a flat plane because you can't achieve an angle without two straight lines. You need a corner, a vertex. A curved line does not allow for a vertex or a corner.
Yeah, exactly. I would agree with that. Okay.
Why don't you just feed back what was said so you can at least confirm that you heard it instead of talking through it every single time Nathan talks?
Yeah, specifically the circle of equal altitude bit with the straight line bit, which could only be achieved on a flat Earth bit. Do you want to repeat those bits back so we know that you understand it could only be done on a flat Earth?
I can give it a stab, sure, if you'd like.
Yeah, that'd be wonderful. Yeah, that big smile in my voice.
Yes, I do. It sounds like you can get by getting an angle I'm not going to use the correct words, but getting an angle to a celestial body, I can draw a line down from there and know where in a line completely around me, there's going to be a circle at which it's all going to be the exactly the same angle from off the horizon.
All the same altitude. Circle of equal altitude.
Angled altitude, sure. I'm trying to deliberately.
No, you seem confused. Not the same angle of altitude.
A circle of equal altitude.
No. You keep adding angle. Just circle of equal altitude. That would be a circle around you that's all the same altitude.
Sure. Yep. Circle of equal altitude. That's what I think you mean.
That would be flat then. That's flat. And to make the measurements with your flat triangle, with its flat bottom, it's got to be flat to do that. Do you understand that? Because that's something you seem to have an issue with, saying it couldn't be done on a flat Earth. And yet it seems, as pointed out 7 times by me, that it could only be done on a flat Earth. Do you understand that? This could only be done on a flat Earth.
I mean, that's obviously the whole topic of debate. That seems why you've got the...
No, it's how you measure it. We've just gone through it with you. It's not being debated. We're telling you how it's measured.
So explain to me the bit where it's flat. I'm saying...
Yeah, the bottom of the triangle to the GP of the star to get the angle is flat. The area around you is considered to be an area of equal altitude in order for this to work. For you to have a flat bottom to the triangle all around you in all directions 360 degrees. All of it must be flat for this to work. That's the 8th time it's been explained to you.
I'd certainly get you repeating yourself. It doesn't mean that the point...
That they don't use a circle of equal altitude and get a flat bottom that you explained to us with a triangle that you explained to us. It doesn't mean that bottom of the triangle's flat. It could be curved or dodecahedron shaped, even though it's absolutely flat and must be for this to be triangulation. It has to be flat, but maybe it's just my opinion and worth debating over this fact of geometry. No, it has to be flat, mate, or it wouldn't work. That's a fact. Not an opinion, not worth debating. A statement of cold, hard fact. Flat.
Yeah, the rules wouldn't work on a curved surface.
Also reiterated by you when you said that this does not prove a sphere, which is exactly why the hell we're here. So...
Nathan,
the 10th man works for the sextant. Let 10th man break it down to it.
So first one, you see a circle of equal altitude. You can see that zenith position of, say, the sun there. And from every position on that circle, it measures 50-degree angle. So that means if this is over the ocean, every one of those sidings would be the same. So this cannot work without the triangle and the straight line that you can see there as depicted. The next slide will show a stick in the ground and the sun at some location over the plane that we live on, and then a shadow cast. So that also gives you an angle as to what you are to the sun, because it's not directly overhead, or else that shadow wouldn't be there. It would be a little or no shadow if it was directly overhead. So to get an angle, you need a baseline. It needs to be zero. It needs to be a straight line. Or else how are you going to get an angle? You can't achieve an angle without two straight lines. You can't achieve an angle with one line straight, the zenith line, and one line curved, the sphere of the Earth. You can never achieve an angle. So a sextant can never work on a globe surface because it's curved. The next slide. You have a depiction of 3 circles of equal altitudes, and this is done so that you can get a fix, F-I-X. So when you do one, you're somewhere on the circle, you just don't know where on the circle. When you do the second circle crosses the first circle twice, so you're at one of those 2 points. When you do a third celestial sighting, then you're able to see where all 3 circles cross, and that is your fix. All that you see there has to be flat for triangulation to work, for an angle to be achieved. The next slide shows a characterization of a person using a sextant, aiming it at the 0 baseline horizon, the flat plane, and sighting a star, and it sights at 25 degrees. This is why you have the books. At the books, you find out where that star is directly overhead on the Earth. The next slide. This shows exactly how it would be done. So here to the left, the middle of the picture is a little characterization of a sextant being used. You got star A right there, 90 degree, and anywhere on that circle is 900 miles away from it. Line of position, LOP. So it's also 50 degrees to that star. And if you go back to the previous drawings, you can see what would happen if you do another star, like you see here, star B, you would have another circle. And when they cross, you are somewhere at that fix. The last slide, a very nice, colorful slide. Here you have the star directly over that part of the Earth called the subpoint, the zenith position, the geographical position, and a circle of equal altitude. Anywhere on that circle to that GP is 3,000 nautical miles, anywhere from that circle.
Right.
The Earth cannot be a sphere.
Right, and if I just flip back to your single depiction on the nice, colourful, globe-based circle of equal altitude on a curved surface nonsense, you've got one circle of equal altitude, and it could be up to, what, 1,000 miles? And then you've got 2 others to get your fix, i.e. triangulate yourself with the 3 different positions, because they're crossing at 2 different points when you've only got 2. So you could be at either of these 2 locations, and when you get the third, you've got an exact location. But that means that all 3 of these circles are all circles of equal altitude with straight lines to get 90 degrees to the GP of the star. Well, this straight line here, and this straight line here, and this straight line here are necessitated to do the triangulation, meaning that all 3 of these circles are all circles on the same level plane.
Exactly. Sextant could only work on a flat plane because you can't achieve an angle without 2 straight lines. You need a corner, a vertex. A curved line does not allow for a vertex or a corner.
That's the best presentation you've given to date, 10th.
Well, we had a live one on the end of the line, so when he said
I just want to say, I saw the whole picture as you were explaining it.
Thank you, Neil. When he said sextant before the close of the live show, I said, what did he say? It just caught my ear. That's why I brought it up again. So I'm glad it was able to be talked with someone who actually thought that the sextant works on the curve. I mean, where do you get that from?
An assumption of a south celestial pole antipode from a north celestial pole.
Ah, the
yeah, so that's curious to me.
That doesn't prove a sphere.
No, not unless you make the
question. Yeah, it doesn't prove a sphere. The reason I brought it up is because I'm curious to know how it works on something flat.
We just explained it. It could only work if it was flat in order to have the straight, flat bottom of the triangle that you're drawing to the GP of each 3 of the stars in their circles of equal altitude. That could only work if it was flat. That's the 9th time I've
I'm
explained
asking about is how do you get
This is
to
all about 3D
opposite
geometry,
poles?
the basics of it.
Yeah, basic stuff.
Yeah, exactly. That's I would agree with that.
I hope it's not going over your head.
I mean, some of it I am struggling to understand, so it's possible I'm missing bits of it. That's absolutely possible.
Oh, okay. Could be just fighting against a cognitive bias that you have.
I certainly think that's something that humans struggle with, myself included.
Indeed. I should have more empathy, but the arena has rubbed all that out of me.
Like I'm fairly fresh to this whole flat Earth, globe Earth debate.
There was something he said about drawing a straight line to the horizon, which runs contrary to the rebuttal to the black swan. You can't hold both those positions, that you're drawing a straight line to the horizon and that the horizon's refracted.
So he said refraction. Well, the sextant plows through any kind of refraction because at 3,000 nautical miles, you've blown through all refraction, all looming, all everything. It doesn't matter what optics are. The baseline has to be zero. It has to be flat. It has to be a straight line. So the refraction has no meaning to the use of a sextant once your star is 3,000, 4,000, 5,000 miles away at its GP. It is getting the correct angle to it, and no optics could affect it.
He mentioned flippantly the South Celestial Pole and refraction. Number one, the South Celestial Pole, that's an imaginary point in the sky. He also mentioned refraction. I don't think you realize what you're saying. It's much like the imaginary point in the sky, because when you bagak refraction, that's terrestrial refraction. You're within a paradox off a mother begging the question fallacy. The paradox is that you got curved atmosphere or curved gases. Gases have no inherent shape. They don't curve. And then you have to know the radius. So when you just flippantly put those terms out, get ready to get your ass handed to you.